Hello people, in this video we want to look at case control study. So basically where are we? In epidemiologic methods you have some studies like observational studies and experimental studies. Two things are there. So some studies, see in that case control is here. So this is what we want to look at. It is a type of analytical study that comes under observation. So you're just doing some observation. You're not doing any experiment. If you're doing any experiment, that will become experimental studies. Under observational itself, you have descriptive and analytical. So analytical is where you're analyzing, and there you have the case control or case reference. Here you are taking individuals as unit of study. So basically what are we trying to study here, guys? We are trying to study the disease, right? We are studying about the disease, the occurrence in people. That is what is epidemiology. Here in observational studies, guys, we don't intervene, right? We just study. But in experimental, they will intervene. In descriptive, guys, that is this one, the first one. This one. Descriptive studies, what will you study? You will study time distribution, you will study place distribution, you will study person distribution, right? Gender distribution. All this you will try to study. Guys, what are we studying? Disease. You are understanding that basic thing, right? This disease and the distribution of the disease in time, person, place, like that, okay? And at the end of it, what will you get? A hypothesis. So at the end of descriptive, what are you getting? A hypothesis. And this hypothesis, you want to accept or reject. Okay, now you have arrived at what? One hypothesis. You want to accept that hypothesis or reject it. That is where your analytical studies will come. What and all will be there in a hypothesis, guys, which we are going to prove in the analytical studies. You will have the population, the characteristics of person, the cause that you are considering, the dose-response relationship, time-response relationship. These will be there in the hypothesis, expected outcome, all that, okay? So that will be there in a hypothesis. Now this is what we want to prove in the analytical study. So now let us say in the hypothesis you have something. What is the hypothesis that you have? Cigarette smoking causes lung cancer. Cigarette smoking causes lung cancer is kind of a hypothesis, but this you have to improve. Smoking 20 to 30 cigarettes, 30 to 40 cigarettes. Smoking 30 to 40 cigarettes per day causes lung cancer in 10% of the smokers after how many years of exposure? 20 years of exposure. These people will get lung cancer. This is a better thing, right? So initially whatever hypothesis you got, that was kind of incomplete, right? You can say it was more like a clue. It was just providing a clue to the disease etiology. So did you understand, guys, why we are doing these analytical studies? Now let's get started with the analytical studies. Now that we understood why we need them, what and all type of analytical studies are there? Ecological, cross-sectional, case control, cohort. Right? 4 things you have to remember. Only 4 names. What and all? Ecological, cross-sectional, case control and cohort. We are actually focusing on case control in this video. Remember that ecological is related to population, but all these case cross-sectional, case control and cohort is all about individuals, right? You can see that here. Case control or case reference with individuals as a unit of study. This is what we are studying now. So basically, they usually talk about case control study and cohort study. We are looking at case control study. So here, from these studies, finally, what will you get? Whether or not a statistical association occurs between the disease and the suspected factor. From the hypothesis, you just got a suspected factor. Now you want to know whether association exists between this. First of all, you will find out whether there is an association between the disease and suspected factor. And then you will also have to give the strength of the association. So 2 things you should get at the end of the analytical study. You should know the exposure, is it? Cause and the disease. And what is the strength of this association? 2 things you should come to know. Okay, so let's get started. This is showing a case control study. So you can see how the arrows are going backwards here. See, this is a backward arrow here. This is a backward arrow here. Again, a backward arrow here. And a backward arrow here. And a backward arrow. And a backward arrow. Okay, so many backward arrows. So basically, you should understand case control study is what? It is a retrospective study. Okay. What you should understand here, the exposure, okay, has occurred before itself. The outcome has occurred, the disease has occurred, the exposure also has occurred, everything before you start the study. So where are you? You are starting the study here. Okay. These people already have disease, they already have the exposure. Some people have no disease, but they may have exposure or may not have exposure. You understood, right? So let us understand this bit. See, there is disease here. You're starting at this point where people have disease, and here you're seeing people don't have disease. These are controls. Now, some of the diseased people have exposure or they don't have exposure. Some of the people without disease have exposure or no exposure. So everything is in the past. That's all you have to understand. So how's it going, guys? Just look at this and try to understand. The exposure and outcome, that is the disease, have occurred before the start of study. The study is proceeding backwards from effect to cause. So you have the effect already. You're trying to determine the cause. And you use a control, that is here, as a comparison group to support or refute on inference. Guys, some examples of case control study you look at here, okay? Adenocarcinoma of vagina. And here they will check the, look at this, adenocarcinoma of vagina. So here they have drawn this table. Here you have the cases, that means people who have disease, right? And here you have the control. In cases, what and all are they showing here? Maternal age is high, maternal smoking, antenatal radiology, they were exposed to rays, estrogen exposure, right? So all these people got the disease. So these people have the disease, right? And you're able to find out multiple causes. That is even great, right? You're able to find out multiple causes, possible causes, okay? These are all the possible causes for this disease. Another example they're giving here, oral contraceptives and thromboembolic disease. So people have thromboembolic disease already. Go back and see whether they used oral contraceptives, right? Let us look at this. What is this? Case control studies on safety of oral contraceptives. What are they showing here? No. What is NO? And percent who used oral contraceptives. Actually, this table is not right. They have put the cases here. And controls they have put here. This is not how the table should be. Always cases should be here, right? And controls should be here. That is how it should be. The diseases should always be here. And this will be A, B, C, D. This is exposed and this will be not exposed. Then thalidomide tragedy, guys. So here they are telling these people have the problem. Okay, they have the similar problem. Just check if the exposure was thalidomide, right? They're going backwards. So that becomes retrospective case control study. You should understand, you're not giving thalidomide to people and then waiting for the disease to happen or some problem to happen. No. This is not what it says. You're going backwards and finding out, now that you have the problem, did you take thalidomide when you're pregnant? Like that. So this is called as phocomelia. Okay. What is it called as? Phocomelia. Where people were born with limbs like this because the mother was given thalidomide in pregnancy for hyperemesis, right? Guys, like this, so many examples are there like this, okay? Look at this, maternal smoking, congenital malformation. So you can go backwards. Congenital malformations, maternal smoking. Leukemia and radiation. So you're going backwards. Leukemia, then go see if they had radiation exposure. If somebody has hepatocellular adenoma, find if they used oral contraceptives. If somebody has Bell's palsy, check if they had herpes simplex infection. If somebody has a spontaneous abortion, go back and check, what is this? Induced abortion history, is it? Then coronary death, if has happened, check about physical activity. If somebody had bladder cancer, go and check if they were taking artificial sweeteners. Something like this. So you're going backwards. So guys, it is retrospective study. Remember, you're going backwards. So the exposure and outcome have occurred before the start of the disease. Okay. And it proceeds backwards. And you also use a control for comparison. So in this, there are 4 steps, guys. We'll come to this. See, you have to select cases and controls. You have to match them in both the groups. Then you will check the measurement of the exposure, just like how you check if there is a thalidomide tragedy, you will check if there was exposure to thalidomide, right? Then analysis and interpretation. Finally, you will come up with the, you will analyze whatever you found and you will interpret the results, right? So you will check the exposure rates and you will estimate the risk. Odds ratio you have to come up with, that is cross product ratio. Okay, this is what you will come up. So where will you get odds ratio? In case control study. Remember, this is very important. Odds ratio, cross product ratio means what? Basically what you did, you have selected some people, right? You have made two groups. You have case, here you have the cases, right? And here you have the control. And then you will go and check if they had exposure to those things, right? Actually, you have to match. Before that, you have to match. So equally, you will put people here and there and match all the criteria, etc. Then you will go and check whether they had exposure, and finally you will make this table, right? And then we have to analyze and interpret. So there are cases here. Give me the thing. So here you have cases. Okay, and here you have control. Okay, so suspected or risk factors present. So present and absent you have to mark. So there was present, so A. Okay, that much, that number, that's a quantity. So out of so many people, yes, these people were having this risk factor, and yes, now the disease is present. Guys, focus. How's it going, guys? Are you able to understand? We have cases and controls in that people can be exposed, not exposed. Same thing in controls, exposed, not exposed. That table you have put here. Okay. Now, after putting this, you have to calculate odds ratio. That is nothing but cross product. That is nothing but AD divided by BC. So, AD divided by BC. That will give you odds ratio or cross product ratio. So, this is what will tell you the strength of association. So, odds ratio is the chances or likelihood of something happening, okay, or being the case. This is cross product ratio. It will measure the strength of association between the factor and the outcome. So, between the factor and the outcome, it will measure the strength of association. Look at this. There are some people who are smoking. Some of them have lung cancer now. And some people don't have lung cancer. Some people never smoked, but they have lung cancer. And most of them don't have lung cancer. Now you are going to take odds ratio, that is A into D divided by B into C. A into D divided by B into C, and you are getting 8.1. So what does that tell you? So it tells you that smokers have 8 times more risk to having lung cancer than non-smokers. Okay. Guys, just do one thing. These values you remember, 33, 55 and 2 and 27. These values you remember because in exams suddenly when you want to calculate, right, you will have to write these dummy values, and dummy values will take time for you. So just remember, if they ask case control study in the exam, remember this table 33, 55, 2, 27, and when you do odds ratio you will get 8. So if you remember this, you can write case control study fast in the exam. So guys, you also have to get the exposure rates, right? From this table you can get exposure rates. The cases, the exposure rates for cases, the exposure rate will be A divided by A plus C, okay. So, A divided by A plus C will give you 94.2%, okay. So, this is the exposure in the cases. Similarly, in the controls, you have 67% exposure. Guys, is it making sense or it's just going above your head? So, did you understand the concept of case control study? Let us look at what problems can be there. Exactly everything let us look at now. Okay. See here you are asking this person to go back in time and they have to recollect, right? So this is the past. They have to find out if they have lung cancer now. They have to remember if they smoked and how much they smoked and all that, right? So it is something like it's in the past. You have to go and it can have some bias. That is, people may forget. So this has a memory bias, a recollection bias. So here there are 5 types of bias that you can write for case control study. Let us look at these. So what is bias first of all? It is a systematic error in determination of this association between exposure and disease. You have some systematic error between the this determination of exposure and disease. Okay. So there can be confounding bias. Memory or recall bias, we just told you, people have to remember what they have done so many years ago. Selection bias can be there where you're selecting people to favor your results. Berkensonian bias is there, and then interviewer bias. Interviewer bias is very clear, the interviewer itself is biased. So confounding means this is some factor which is related to both the exposure and the outcome. To both of it is related. It is associated with both the exposure and the outcome. So it will give a mistaken estimate of the outcome. For example, there are a lot of people who have lung cancer. Okay. And you will check that all of them are men. All men. Okay, most of them are men. Whoever has lung cancer, most of them are men. So then what you will say, men have higher incidence of lung cancer is what will that will be your conclusion. But what you don't understand is, it is smoking that is related to men and smoking that is also related to lung cancer. So smoking is the confounding factor which is related to both men and lung cancer. So that is where you will have a mistaken estimate of the outcome. Hence what you should do, you should do matching, or there are many other ways, randomization. When you're selecting people, you should do matching so that you can remove this confounding. So you will do equal distribution of the confounding factors in both the groups. So in cases and controls, you will take equal distribution of these confounding factors in both the case and control groups. So memory or recall bias, right? These people have to recall the existence of certain events or factors, so they could be wrong, right? Then selection bias, guys. When you're selecting people itself, people may be chosen such that it favors their hypothesis. They want to prove their hypothesis, right? And they will select people in such a way. So again, here they want to do randomization, etc. What is this Berkensonian bias? See, this is something like, here you're going by the disease, right? You're first going by the disease. So you may take these cases from the hospital. So basically here you should understand that the disease has occurred and you're going backwards and you're getting the exposure, right? So you're going from this disease, right? So if you may be taking hospital admissions as your information, the Berkensonian bias comes that different rates of admission to hospitals for people with different diseases, that is the Berkensonian bias. So different rates of admission will be there to hospitals for people with different diseases. So remember guys, you're taking the cases and controls from the hospital and the hospital admission rates may vary. So you should be careful about that. Okay. Then coming to interviewer bias. So basically it is the interviewer who's asking these people, cases and controls, that did you smoke 20 years back, how much you smoked, etc. But now this interviewer knows who has the disease and who doesn't have the disease. So he may be able to, put some bias into it. So all this can be eliminated by double blinding. Double blinding is a very good solution where even the people don't know in which group they are, where they don't know whether they are the case or the control, and even the interviewer doesn't know whether they are the case or the control. If possible, then you should apply this double blinding. So guys, we are almost done with case control study. Let us now look at the advantages and disadvantages of case control study. Are you able to see? Let's look at the advantages. See, this is very easy to carry out, right? You may just have to finish it off very quickly. Just take the diseases and go check 20 years back what these people have done. Also, if you want, you can check, and your job is done. It's a very easy thing to do. So let us say it is a relatively easy thing to do. Okay. Then rapid and inexpensive. It is rapid. Immediately you are going back and checking, and it is inexpensive, right? That is a good thing. But imagine if it is a cohort study. In cohort study, what is happening? You are, the people are smoking and you wait 20 years and see if they get lung cancer. That is going to be a cohort study, right? So you're not going forward. In our case, you're going backward. So the person has the disease and you're going back and checking if he smoked. So this is going to be rapid and inexpensive, right? You don't have to wait for so long. You don't have to do follow-up, etc. Now, require comparatively few subjects. You just need few subjects. That is enough, right? Particularly suitable to investigate rare diseases. Rare diseases will occur rarely. So if you catch hold of these people who have the rare disease, they already have this rare disease. Very few people will have this rare disease. Just go backwards and see what it is that is common to these people in terms of exposure, risk factors, etc. Right? So easy to do a rare disease. But imagine in a cohort study, let us say a cohort study, you have to go forward. Okay. So now these people have some, you think this could be the cause. Then you wait 20 years, 40 years for the rare disease to occur, and the disease may not occur or may occur. Right. So cohort study doesn't work for the rare disease, but case control study works for rare diseases. Okay. Then here they are saying Leukemia in adolescents may not happen. It's a rare thing. But for people who have prenatal X-ray exposure, they can have leukemia in adolescents. Okay. No risk to subjects. Here, the disease has already occurred and you're just going backward to find out whether they smoked, for example. But in cohort study, you're just checking these smoking people and then you're waiting for 20 years for the disease to occur. That is like leaving the risk there, right? So you're leaving the risk there. People are smoking. That is not a good thing. So cohort study doesn't work well that way. So case control study works better. Why? Because there is no risk to the subjects. Allows to study several different etiological factors. So now the disease has occurred. You can check, did you smoke, did you drink alcohol, did you have X-ray exposure, did you have that, did you have this. So you can possibly get different etiological factors for the same disease. Risk factors can be identified. Guys, are you okay? Is it just going above your head? Shall we continue? Okay. Where are we here? Risk factors can be identified. Yes, you can find out the risk factors. Rational prevention and control programs can be established. So you can plan some prevention and control. No attrition problems. No attrition problem means if you started off with 3 people. Okay, let us say we started off with 3 people. You are just asking them questions. That's it. These 3 people are with you. They're not running away. But now let us say cohort study. You found some 10 smokers and you have to follow them up for next 10 years, right? And after 10 years, you have to find out if they got the disease. So these people, they can go missing, they can die, they may not cooperate, etc. So in cohort study, there is a problem of attrition. However, in case control study, you don't have attrition. Okay. Ethical problems are minimal. Ethical problems are minimal. Why? Because they already have the disease here, and you're just finding out what could have caused it. But in cohort study, probably this is the cause, and they are allowing them to smoke so that they get the disease. So ethical problems are minimal in this case. Now let us go to disadvantages, guys. Guys, we are moving to disadvantages of what? Case control study. So there's something that is not right also. Everything sounds so rosy till now, but everything may not be rosy. Let's see the disadvantages. Okay. So here there is something called as a memory or recall bias. This we know. So there's a bias. Okay. A selection of an appropriate control group is difficult. Case is very easy. These people have the disease, you will find out. But how do you find the control group? It's kind of difficult. We cannot measure incidence. You can only estimate the relative risk. That is why we have something called as a odds ratio. So the odds that these people will, could be the cause, that is odds ratio. Relative risk you don't know because you don't have the incidence. Does not distinguish between causes and associated factors. See, you're just saying these are the things, smoking, alcohol, age, male, all these things, X-ray exposure. But you cannot distinguish what exactly the causes and the associated factors are. You cannot distinguish, they are saying, okay. Not suited to the evaluation of therapy or prophylaxis of disease. You cannot treat. Not suitable for evaluation of therapy or prophylaxis of disease. So therapy, yes, we are not looking at any treatment or anything here. Another major concern is the representativeness of cases and controls. How well they represent themselves. Okay. So that's it, guys. So here we have spoken about the advantages and disadvantages of case control study. So that's all we wanted to cover in this video. Let's take a recap. So case control study, guys, is a type of analytical epidemiology where you're going backwards. Okay, so you can see you're going backwards here. All the arrows are going backwards here. You're starting actually with the cases, that is the people who have the disease, and you're going backwards and finding out whether they had exposure or no exposure. And then you will find the strength of association. So basically it's a retrospective study where the exposure and outcome, that is the disease, have occurred before the start of study. You are proceeding backwards from the effect to the cause, and it uses a control or a comparison group. So you will have cases and you will have controls, right? And you will use this control as a comparison group. Then what else? Examples, guys, you can remember very well thalidomide tragedy. If people have phocomelia, go and check whether they had thalidomide exposure. Right? Something like that. And if somebody has thromboembolic disease, find out whether they were taking oral contraceptive pills. Something like this. You go backwards, basically. If somebody has leukemia, find out if they had radiation exposure. If somebody has congenital malformations, find out if the maternal mother was smoking. If somebody has Bell's palsy, find out if they had herpes simplex, right? Something like this, okay? Then basically here it is the past. People have to recollect what happened at the previously. So this is an example of the 2x2 contingency table. So where you are putting the cases, that is if disease is present here, and the control where disease is absent, and cases can have exposure or no exposure. So this is your case control study. Mainly remember this. Steps will be, you will be selecting the cases and controls. Then you will be doing matching. So matching will remove confounding, etc. Measure the exposure. So all this you will interview people, get the information that you want. And then once you get the data, analyze and interpret. You will find out the exposure rates for the cases and the controls. You can do that, right? And then you can estimate the risk by odds ratio, that is cross product ratio. So that we have seen in odds ratio video. Remember this table, it is better to remember these values also, because in the exam when you are writing theory exam, you have to suddenly give examples, right? So just remember cases with lung cancer, how many people were smoking and how many people were not smoking. Cases without lung cancer, how many people were smoking and how many people were not smoking. So remember 33, 55 and 2 and 27. A, B, C, D, and your odds ratio will be AD divided by BC. So AD divided by BC will be your odds ratio. So you're seeing 8. So what does 8.1, 8 or 8.1 means? So the smokers have 8.1 times risk, compared to non-smokers, that they will get lung cancer. Guys, and this exposure rates, they have some P less than 0.001. All that you should know, p-value, etc. Okay, if you want, you can look at that from textbook. So you have looked at the steps. Now coming to bias. Bias means you will say there can be confounding bias, because this confounding thing can be associated with both the exposure and the outcome. So you will have to do matching, randomization, etc., stratification, lot of things to remove this confounding factor. Then memory or recall bias can be there, because this is retrospective. People have to recollect what they did. And selection bias can be there, where people are selecting people such the way that they can prove the hypothesis however they want. So selection bias can be there. Berkensonian bias means we are going by the diseases, so hospital admission rates may vary. Interviewer bias may be that interviewer knows this person is a case or a control, and he may interview them differently. So basically, to remove interviewer bias, etc., and selection bias, etc., you can have double blinding, where people don't know which group they are in, case or control, and interviewer also doesn't know. An interviewer has to spend equal amount of time between the case and the control, and he should ask the same questions to both, like case and control. Like the questionnaire and the time spent on both should be same. So all that will remove the bias. What are the advantages we saw? Basically, this case control study is relatively easy. It is fast. It is inexpensive. You just need few subjects, right? You just need few subjects, and it is suitable to investigate rare diseases. There is no risk to the subjects. There is no ethical problems. It's minimal. You can study different causes, and you can find the risk factors and how to prevent and control programs you can devise. There is no attrition problem. Mainly remember this, there's no attrition problem. Coming to disadvantages, you cannot differentiate between the cause and associated factor. It depends on memory, and there can be a memory or recall bias. Then what else? You cannot, it is not easy to select a control group. Selecting a control group is difficult. We cannot measure incidence, so relative risk you cannot know, but odds ratio you can come up with. It does not distinguish between the causes and the associated factors. It is not suitable for evaluation of therapy or prophylaxis of the disease. There's nothing about prophylaxis or the treatment of the disease here. Okay, that's all for now, guys, in this video on case control study. Remember, if they ask you framework, you have to just draw that 2x2 table. This is the framework, guys. Framework means you have to draw this 2x2 contingency table. Remember, always disease will be here. Okay. And in that exposure, no exposure will be here. Disease will always be in this part of it.